Hey everyone, a warm welcome to hok'stutoring. Today we'll be doing chapter 7C, which is the integration chapter, or more specifically integration by substitution topic of your maths textbook. So before I introduce you to what a simple substitution is, let's do a little bit of warm up, to warm ourselves up. How would you differentiate this function right here? So if you were to differentiate this, you would have to use chain rule, or you can expand it, but then that just takes a lot of time, right? So let's use chain rule, differentiate it first, and then let's move on to the topic. If you want to use chain rule, you bring the power down. So in that case, we bring the 3 down, and then you leave the function inside the bracket the same, minus the power by 1, so 3 minus 1 is 2, and then you multiply by the derivative of the inside. So in this case, you get 4x, because 2, you bring it down, that's 4, and then minus power by 1. So it's the same thing, differentiating polynomials. And what you end up with is 12x, so 4 times 3 is 12x, and then you get 2x squared minus 1 squared. Okay, if I was to differentiate this right here, this is what I get. Now the goal with integration by simple substitution is you're going to work backwards. You're going to be able to anti-differentiate this function, the one you answer right here, and to get back to the original. So get back to this function right here. So how would you do that? Assume that we have no knowledge of this function at all. We're only given this function and we're supposed to anti-derive it and get back to an answer, right? So how would you do that? Well, the problem with this is that there's a lot of functions going on. There's one function, that's another function, this one has a square on top of it. Now, one way of doing it is you expand the whole function, this bracket, multiply it out, and then anti-derive it using the polynomials way. But that can sometimes be quite long. What happens if this power becomes like 10 or something? That's way too long, right? So there has to be a better way, and that better way is simple substitution. So I'll show you the magic here. So if you want to derive this, you let u equals to a function inside the integrand. So you let u equals to one of the function, and in this case I'm going to let u equals to 2x squared minus 1. So what we're doing is pretty much like anti-chain rule, but not really. It's just a way to anti-derive these functions. So let u equals to 2x squared minus 1. It's usually the ugly looking function. So I guess that's a rule of thumb. It's not always the case, but the rule of thumb is u is always the one that looks ugly, okay? And then you derive the function that you just have. So the u dx, you get 4x, okay? So the u dx is now 4x. And from here on, your teacher might show you a different thing, but what I like to do, this is just to help you visualize it. I can write dx equals to du over 4x, because now all I'm doing is I'm swapping the dx and the 4x, okay? So it's just swapping them. So now is dx the subject, o equals to du over 4x. And what you do here is, here's the magic, okay? I'm going to rewrite the function in terms of u. So 12x is fine, but now 2x squared minus 1 is u, and we have a square, so it's u squared, and then dx is now du over 4x. And what can you see? This x cancels out, okay? And you're left with, what you're left with is, 12 divided by 4, that gives us a 3. That gives you 3u squared du. And this, if you have a look at this function, we've only got one variable, one function, and it's a polynomial, right? And you're anti-deriving in terms of u. Can you anti-derive this? Yes, we certainly can. When you anti-derive polynomials, you add the power by 1, that gives us a 3, and then you bring the 3 down, that's 3 divided by 3, that's 1, and you're left with a plus c every time. So we chuck back in what we let u equals to. So in this case, 2x squared minus 1 cubed plus c. And if you look back to what we have originally over here, that's a 2x squared minus 1 cube, and this is our answer, okay? So this is integration by substitution. It's a pretty good technique. It's pretty clever, but yeah, I'll summarize it again. If you want to anti-derive these, it's usually in the form of two functions. You let u equals to usually the function that looks ugly. So in this case, 2x squared minus 1. And then you want to derive it so that you can eliminate the other function, and you'll be left with only u in terms of u and with only one function. So that's pretty much the goal of integration by simple substitution, okay? So guys, just a quick simple video on this. I'll be going through some example exercises in next video. So if you want to have a look at that, just click the link or on the pop-up above and I'll see you in that video. But aside from that guys, thanks for watching and I'll see you next time.